Okay, so here we go, lecture 38. Let's look at this idea of determinants. Now, I don't believe in mathematics there's ever a magic number. No, there's no magic number.
Okay.
Everything comes from something. Every formula we have comes from somewhere. We can derive it, we can find out mathematically where it comes from, we can something, okay? Determinant is about as close to a magic number as I've ever seen, okay? I have never had a class where we've talked about the history of determinants, okay? So it is one of these things that we will show you a couple applications of it, and you'll be like, yeah, it's kind of magical, okay? So first of all, the definition. I have it up here. The first part says it's a scalar value. All that means is it's going to be a single number, okay? If your matrice only has integers, then your determinant will be an integer.
Integer again?
-1, 0,
Okay.
2, 3, -5. If your matrice has fractions, your determinant could be a fraction. If your determinant has irrational, your determinant could be irrational. But it's a single value. Basically, whatever type of numbers are in your matrice, that's what your value will be like.
Wait, it's
That
not
person.
like the 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that's not what that single number means.
No, a single value just simply means it's a single value, not a single digit.
Okay.
So it could be 43,
Okay.
could be -17, could be 147.
Oh, okay.
Okay, but it's going to be a single value, a single number. Okay, that can be computed from only one type of matrix. It has to be from a square matrix. So 2 by 2, 3 by 3. Rows have to equal columns. We're not going to get bigger than 3 by 3, but I'm going to give you the tools to find whatever size we give you. But we're not going to in class give you more than 3 by 3. Okay. Now there's two ways to denote it. When you see it on a calculator, if you look at the yellow calculators or maybe what's it called, Desmos, okay, you'll have this determinant DET with parentheses A. By hand, what notation does it kind of look like?
Absolute value.
Kind of looks like absolute value. So absolute value will kind of be our symbol for, except with the matrix, it'll have a matrix in there, just one value.
Mhm.
It'll have a 2 by 2 or 3 by 3, but rather than writing it as brackets, 1, 2, 3, 4, it'll have parentheses 1, 2, 3, 4. It'll look like that. So it'll be the absolute value symbol rather than the brackets. Okay.
So then what if it's like the one, well, I really forgot what it's called, the one that has the 0, 9, reduced echelon form, where it has like one of those. So is it gonna have like 3?
So you're talking about like, say it again, you were talking
The
about?
row echelon form.
So like it's broken down to like zeros and ones?
Yes, but then it's like also like the split, like the answer also has a straight line. So
Okay.
is it 3 straight lines?
Interesting, no. We'll talk about how we apply it here in a little bit. But you can only have a determinant of a square matrix. So like in the ones we were just dealing with, the systems equations, it's
Yes.
augmented matrix, right?
Yes.
On the left-hand side was a square matrix.
Yes.
So I can take a determinant of the left-hand side with the answers. And we'll see how that works here in a little bit.
Okay, my bad.
That's right. So first of all, let's figure out how to find the determinant, okay? So there's the definition, there's what it is, there's a notation. We're gonna start off with 2 by 2. So number 1, start off with the 2 by 2 matrix. So in general form, notice we're gonna use the absolute value symbol, not the brackets. And I'm just gonna put in letters A, B, C, D. Okay? So A, B, C, D. Now, to find the determinant, you're gonna start at the same place we always start, which is the top left, right?
Yes.
We're gonna start in element A11. And we're gonna go A times D, so AD. And we're gonna do the opposite, the other angle, CB. I'm gonna put in alphabetical order BC. And you're gonna subtract the difference.
Do that.
2 multiplications and a subtraction. Okay? And that would be the determinant of that particular matrix. So, let's say we give you matrix A. Oops. Is equal to, I don't know, let's say -1, 5, 3, -2. and ask you to find the determinant of A. So we simply do, what is negative 1 times negative 2?
2. Positive 2.
Mm-hmm. And then I'm going to take the up ones, 3 times 5.
15.
8. Oh, sorry, 15.
Yes, multiply. And then I'm going to, in between, I'm going to subtract them. So negative 1 times negative 2 gives me 2, minus 3 times 5 gives me 15. So my determinant is a single value, negative 13.
It's always across like that.
When
It's always across.
2 by 2s.
Okay.
3 by 3s, we're going to have to do a little bit different. Okay? But if you can get a 2 by 2, you can do 3 by 2s.
Okay.
Okay? So it's down minus up. Got it? Got it?
Yes.
V, you good?
How are
Are
they?
you good, Allison?
Yeah.
Like woven, like my bad. I keep on
I'm trying to do what?
trying to go farther.
Go for it.
Push limits. Also.
Redefine gravity. Okay.
Do you know wicked?
What?
Wicked, the movie.
Never seen it. Equals, find the determinant of 2, 7, C, 5. You will have an answer with a letter in it. Because there's a variable in here, so you have a variable in here.
Oh.
Because we have a variable now, it's not gonna be a single number, there's gonna be a variable in my answer. And what is my answer?
10 minus 7c.
10 minus 7, C, is my determinant.
Is that Z?
C,
Oh.
10
No.
minus 7, C.
No, is that Z7C5 or is that 27C5?
2.
Okay.
Remember my Z's, I was going like that.
Okay.
So is that the determinant?
That's the determinant.
Or the
And remember, whatever's in here is gonna be my determinant, so this is integers with a variable, so is integers with a variable. Back up here, we had integers, my answer's an integer. There's no way to get a fraction, unless there's a fraction inside my matrix. Okay, so along comes a guy, let's see, Roman numeral 1, let's do Roman numeral 2. Along comes a guy named Kramer. And he comes up with this rule that's actually quite fascinating. Let's start this, I don't know if we'll finish it today, we'll get through part of it. But let's take a system of equations, but let's not use numbers. Let's use just variables, okay? So we're gonna go AX plus BY equals, let's go M. And on this side, we'll do CX plus DY equals N. Okay. Now, A, B, C, D, M, and N are just gonna represent numbers, right? 5, 2, -1, 16, something. Just like what we did on today's quiz, they just represent a value, a number. Okay? So X and Y are my two variables. So a system of equations, but I don't have any numbers. Just A, B, C, D, M, and N. Okay? But they represent any number. Okay? So let's go ahead and let's solve this one. And let's go back and solve this using old-fashioned elimination. Way back when we did substitution elimination, let's do it by substitution, so by elimination. So I'm gonna take the top one, and I'm gonna multiply by the coefficient D. Okay? And I'm gonna take the bottom one, and I'm gonna multiply the coefficient B. Okay? So multiply all the top ones by D, all the bottom ones by B. So I'm gonna have ADX plus BDY equals DM. and I'm gonna multiply the bottom one, I'm gonna have BC x plus BDY equals BN. Now, what do you notice about these two equations?
They're both positive. They're both positive. for
What
like-
else do you use? Yes,
They both have BDY?
both have a BDY. So what happens if I subtract these two equations? What's gonna happen to BDY?
You're gonna cancel out.
It's gonna go bye-bye. So subtract. So I'm gonna have ADX minus BCX, and of course that BDY goes away, equals DM
Plus.
minus BN.
Right. Oh, yes, okay.
Alright, now, what does the left-hand side, as you write it down, what's the left-hand side have in common? ADX and BCX.
X.
Both have an X in common, right? So let's factor out an X, and I'm left with AD minus BC.
Oh.
Have you seen that anywhere before? Have you seen AD minus BC?
Oh, right, determinant.
It's the determinant. It's the determinant of these four numbers, of the left-hand side. Okay. Equals, on this side, they both have anything in common, do they? They have DM minus BN. So if I divide, x equals DM minus BN over AD minus BC,
Oh,
You get X.
say it again,
You get.
we're gonna get x. And what we notice is the top is in the same format as the determinant, AD minus BC. It's in the same format, two numbers multiplied minus two numbers multiplied.
Right.
So this is actually called Kramer's rule. We can do the same type of thing to figure out y. And when we come back tomorrow, we're gonna show you how to take a system of equations, and what I think is the easiest way to solve it, we're gonna use Kramer's rule. Okay? And that's where it kinda comes from.
I kinda need numbers now.
Say it again?
I need numbers.
Yes,
Like-
and tomorrow we'll actually go through and finish this, and then we'll pick it up with, not tomorrow,
Wednesday.
you guys have thoughts on Wednesday? So on Wednesday, we'll go through this again, and then we'll pick up from there and, actually do numbers. Have a great day.
Yes.